Welcome everyone, and thanks for joining us at the Scale Bar and Grill happy hour here. My name's Dave Demlow. I'm the Vice President of Product Management. You can see my Twitter handle here. I'm going to start with a brief introduction, refresher on Scale Computing and kind of some of our milestones, dig into our competitive differentiators, and for most of this session, we're really going to be focusing on the applications of hyperconvergence and remote management for edge computing applications. So, for other viewers from our previous history, we have many other Tech Field Day events where we drill into the architecture of the product, our software-defined storage layer. Highly recommend that you look at those. All those technologies are still in use and very relevant to our current project. So, kind of the key, hyperconvergence, most of you understand the meaning of that, but what we provide is all-in-one virtualization infrastructure. So whether that's in a single location, whether it's for an SMB or mid-market customer, or a large multi-site enterprise that has distributed edge locations, we focus on that all-in-one infrastructure and providing radically simplified infrastructure and management. So resilient systems that detect hardware errors, correct systems automatically, don't require an IT administrator to get in a car and drive out to a remote field location to keep operations up and running. The high availability aspects are designed into the system along with the simplified management capability, and then we wrap it all around very comprehensive support. In most markets, we're selling full appliances, so systems come preloaded with all the software, with support included. One phone call to Scale Computing addresses your hardware, software needs, everything very simple. We sell across all industries. Are very strong in the retail space, areas such as healthcare, education, financial services, manufacturing, and government. We're headquartered in Indianapolis, Indiana. We're here broadcasting now from our R&D facility in San Francisco. We have over 3,000 clusters that have been deployed on the HC3 platform, and this is in the hyperconvergence space, 10,000 systems. Our Net Promoter Score, we religiously survey our customers on their customer satisfaction, both on the product, services, and the support side, and maintain an average of 91, which is very high on that 100 to negative 100 scale. You can see our partners. We have hardware featured from many of them, Intel and Lenovo, that we'll be using for some of the demonstrations here today. And we also partner in a couple other specialty markets relating to edge computing. We have a partner, BCD Video, that specializes in the video surveillance and facilities management, and then a couple companies that we partner with in the VDI space. Quick overview on hyperconvergence. Again, all-in-one virtualization infrastructure, so we're focusing on unified management. Everything that you need is built in. The storage is pre-configured. You can literally deploy a system in well under an hour. I think the record is about 18 minutes. High availability is inherent in the system, so it's self-healing. It detects events, detects coming events, such as a drive that's reporting excessive errors. It may still be functional, but we need to remove that from the system for a redundancy standpoint. Integrated backup and replication, so HC3 systems, whether they're in the same location or multiple, can replicate to each other. Easy failover and disaster recovery, whether it's hosted by customers themselves, whether they're working with managed service providers to provide disaster recovery as a service, or we also do offer a Google Cloud-based DR as a service offering. Scalability, and we'll talk a lot about, particularly in the edge environment, the ability to scale and run production applications even on a single node, but within that centralized management umbrella, seamlessly scale out as your compute and storage needs change, and the ability to mix and match. We really take a strong emphasis on investment protection, of being able to take the systems that you've already purchased and deployed, add newer, better, faster systems without disrupting your environment, and focus on affordability. So it's the complete stack, as I mentioned, no extra software licensing, your hypervisor, your management software, your orchestration capabilities, if you're looking at an edge environment, are built in, and overall at a low price and lower cost compared to building the parts, building the system on your own from piece parts. Common, hyperconvergence versus virtualization. This is the common architecture of modern virtualization. You've got servers from vendor A, you've got hypervisor software from vendor B, you may have storage software from vendor C, you've got management infrastructure that needs to tie it all together and bring it all to run applications. Hyperconvergence, and specifically when you talk about the model we've selected with HC3, actually eliminates all those capabilities. We didn't just take the storage piece and say, hey, it's running on Intel hardware, let's throw it in a virtual machine and eliminate that piece of hardware. we actually simplified the infrastructure, the underlying architecture for performance, for scalability, and this is just an example of that kind of model. If you take a virtual storage appliance model where you still have a separate storage layer, a separate operating system that's managing storage, separate networking connections and network protocols that are managing storage, that becomes a very heavy-duty application that you need to support and run in order to provide high availability, in order to provide hyperconvergence. When we're looking especially at little, tiny nano devices like these, we'll go through and kind of look at the resources that you're consuming by that separate storage stack that we can eliminate by converging the software-defined storage, converging the management directly into our underlying operating system. So just as an example, in a VSA model, you might consume anywhere from, in a 3-node cluster, 96 to we've seen several hundred gigabytes of RAM consumed by the storage layer, particularly if it's providing a more advanced functionality. But in our system, we'll actually show systems here where each of these little tiny devices are using less than a gigabyte of RAM, and that depends, that's per node depending on the applications, the infrastructure, and so forth.
So if I can ask a question, when you're talking about VSA, you're talking about specifically about edge deployments, right? So
well, not necessarily. I mean, this is just an architectural.
Okay, you're not talking about other HCI platforms.
We're talking about both. I mean, HCI as an architecture can be deployed in a core data center, like many of our customers do, can be applied out on the edge. I do think the cost of even little differences in efficiency, like, hey, how many cores, how much RAM am I applying just to serve up storage and serve NFS packets or iSCSI packets, becomes magnified, certainly when you're talking about 10,000 locations. So that's one of the things we'll highlight here is any bit of efficiency that can let you use your compute resources most efficiently for your applications, that can eliminate costs, that can eliminate performance gaps, extra latency, things like that, just goes to your bottom line and gets magnified when you're talking a large number of sites. And just different things to manage. I mean, we don't really go into it in this module. There's others where I think we do a little more deeper dive on, virtual storage appliance architecture versus hypervisor embedded storage. I mean, that is just obviously now two things you have to manage and update. We have one single stack. When we apply an update for HYPERCORE systems, that's our operating system kernel, it's the hypervisor functionality, it's the storage functionality, it's the management, and it's all deployed in literally one click as a single unit. And again, now that efficiency, that reliability is even more important in a distributed edge environment. So does that answer your question? Okay, thanks. So what drives the need for edge computing? I'm not going to spend a lot of time on this, but in terms of what we see in our customer base and the customers we're targeting, data explosion, all the new applications that are collecting data, video surveillance, IoT, so forth, that need to quickly store and process that data. The need for resiliency so that those decisions, the data can be analyzed, real-time decisions made quickly and responded to without round-trip delays to a remote system. Latency kind of is the next thing of the classic edge example of a self-driving car where you can't send the enormous amount of information you need off to Google, wait for a response that says, hey, there's something in front of you, you need to stop. Just laws of physics that dictate local processing, in many cases regulation. And the core of all this is autonomy, the need for infrastructure that can run in the edge without requiring external network access, and in many cases without requiring IT people to be there carrying and feeding and monitoring it and able to take care of things quickly enough. Edge computing requires simplicity, so you need that autonomous automation. You need a system that can detect, prevent wherever possible, and absorb failures, so it's not a fire drill in the middle of the night or rolling a truck with parts in a critical operation. The edge sites that we deal with almost universally have no IT staff, and very often no IT staff within a day's drive, so they're relying on third-party vendors or manufacturers to provide that. Ease of use is essential, and this is ease of use not just within a single system, but through the entire life cycle of how do you acquire, how do you deploy these, how do you deploy your applications, how do you update the entire system, and then how do you evolve it as your application needs grow. The sites need very, very quick deployment and need to be able to deploy. We have customers we're working with that are deploying multiple edge locations a day and doing this continuously, need that to be quick and automated and reliable, obviously. And then, the day two type of operations, being able to have them managed remotely with ease. So some of the specific things getting into our technology, and we do have an offering called HC3 Edge. It's based on our HC3 overall product family and our flagship product. So it has all those inherent things that we get from being based on that architecture, designed for autonomous self-healing operation, ultra-efficient resource usage, which really becomes important when you're talking about some of the kinds of devices that we'll be digging into a little bit more here. All the integrated pieces, virtualization, storage, management software, networking capabilities, as Phil's going to demonstrate later. And it's designed to handle all edge-based workloads and applications, and not to be ignored are those legacy applications, the things that have to run in virtual machines, the things that are going to stick around for years and years and years, as well as the new modern designs and being able to add nodes with new capabilities when you want to do a video streaming analytics operation. You can easily expand storage capacity, compute resources, and so forth. So these are things that are virtual machines, virtual appliances, maybe network functions, containers, analytic-based applications, and so forth. So our offering in Edge is designed to be able to accommodate all those. Flexible licensing options, and just to kind of clarify, at this level, I mean, obviously if we're looking at a 10,000 location edge deployment, these are custom. These are not off the shelf, buy these price lists and so forth. So we work with the customer, we work with their workload, their budgets, the hardware needs, requirements, their applications, their deployment strategies, and we can customize all of those things, including what's the best licensing and consumption model for them. And we can actually deploy and deliver edge custom software. We actually have customers that every single time we make a significant change to our core operating system, not only does that get regression tested and released for our HC3 appliance business, it actually gets the same capability as tested and deployed and available to edge customers, to OEM customers that private label our software. And that can include things that are unique for each thing. So customer A may have a particular deployment methodology, so they have a zero-trust deployment script that points to such and such internal server in their infrastructure. We'll go through a little more details, but things like how their networks are configured, system defaults, security information, accounts and certificates. We can brand those and make those custom per edge customers depending on their needs. So we actually do deliver out of the same code base, same infrastructure pool, unique capabilities that can meet the needs of specific customers. So on the efficiency, I kind of went over here. You can see along the right side, this is a machine with 32 gig of RAM, and imagine a 3-node cluster of these. If you are running a virtual storage appliance that's consuming, in addition to using up some CPU and cores and networking resources, let's say the CVM or the VSA storage controller requires 24 gig, which is very typical. That now leaves you with maybe 8 gigabytes of RAM available that you can do work, run applications, versus our operating system out of the box with kind of full capabilities, nothing turned off or hidden. We reserve 4 gigabytes, and often it's much, much less than that, and we can tune that down for edge environments and specific hardware. This shows some different cases. I mean, now say you want to, cut costs. Again, we're looking at how we can make a 10,000 site deployment. If we can save $30 per site or $100 per site, that's, real significant money. What can I do on a 16 gigabyte platform? Well, if we can still even use that 4 gig, that leaves, 12 gig available to run. If we need to maybe tune it down to run a little more, we could even use more. Say it's an 8 gig machine. We have machines here with 8 gigabytes of RAM and actually less. We can tune down even further. We'll actually show here. Actually, let me switch over right now at this point. This is the best way here. No, not what I want to do. Here we go. So this cluster is actually, we're connecting to here. This is the one on the middle board here. Each of these nodes have 4 gigabytes of RAM. I've got some clone virtual machines of Windows and Linux that I have from my master. I'm going to go ahead and spin those up. For many of these edge applications where it's 2, 3, 4, maybe 5 applications, maybe some containers going in, you can do an awful lot of work, in this case with 4 gigabytes of RAM. Let me tell you a little bit more about this cluster. So this is, again, the middle one on the board. This is based on Lenovo, their Nano product line. So this is an N device. It's a fanless machine. Each node has 4 gig of RAM available. There's 1 drive in each of these. They're clustered together. The network connections, the way we have them set up here, are somewhat unique, but interesting. The Ethernet ports, if you should take a walk up later, or maybe you can pop in a picture to the video, are all cross-connect cable to them. So if you're familiar with the HC3 architecture, we have what we call our backplane connection. It's a logical concept, but this is where all the node-to-node data mirroring management traffic goes. So those are all cross-connected Ethernet cables connected between those nodes. So all the nodes need to do, and any east-westbound applications all occur there. They have Wi-Fi built into these, and the public access to this whole cluster, including my web user interface here, including virtual machine traffic, is all over Wi-Fi. So, I mean, this could be easily put up on a wall and deployed with simple power, provide plenty of application for running a lot of, quick serve stores, gas stations, things like that, with full high availability and all the things you get out of a remotely resilient system, including rolling upgrades with no downtime and all those benefits. And if one of these things fails, it's no problem. The applications keep running. There's plenty of resources available on the other systems to go. And this is kind of the extreme small. But there are many companies with many applications that fit into this profile that today are rolling the dice on single servers and crossing their fingers and paying big bucks for service companies that are going to show up with parts in 4 hours and things like that we can provide them other options and alternatives there.
What sort of applications are you actually seeing your customers deploy on these really tiny devices on the edge?
The things they're interested are, a lot of these, again, a lot of the focus early on has been in retail and retail-ish, so hospitality, quick serve, gas stations, and so these are the POS back end. These are environmental controls. These are loyalty applications. All those kinds of things that today are probably running on a couple different boxes in some, or maybe they virtualized and they have all their eggs in one basket and a whole bunch of things running on a box and are crossing their fingers. It's those kinds of things, but it's very vertical specific. A lot of legacy applications, that. Hey, the hardware, they can't get parts for their old hardware in a lot of cases, and this is a way of modernizing those, moving them over, getting all the benefits of hyperconvergence, virtualization, and being able to manage them all remotely. So, but very vertical specific.
Dave, are these all x86 boxes?
These are all x86.
No, no intention of having anything ARM-based or anything else?
We were asked that earlier. At this point, we haven't had a customer ask us for that or had applications that they're deploying for that, but we're a Linux-based operating system, a lot of open source components. There would be no major technical bar to being able to do that if the right application came along. So, but yeah, at this point, the demand has been in x86, and a lot of that being they have these legacy applications that they've got to live with for quite a while. They want to deploy new applications alongside that, and we give them the ability to do both of those very easily.
So, quick question for you as well.
Sure.
And I'm completely new to Scale, so I guess my question is, where's your delineation? Where do you stop? Right. So I understand we have the hardware here, which is something you work on, but then also, are you then the hypervisor? Is that where does Scale stop providing services and the customer takes over with putting an application on?
Okay. Well, so we in our standard flagship business, and some edge customers want this level, we provide appliances with the software preloaded. Literally, they come and the customer powers them on, plugs them in, gives them IP addresses, however they do that.
They provide you the software they're looking for, or is
No, and then they migrate their applications over. So we can do P2V, V2V. We can take things that we're running on a Linux app on this box or a Windows app on this box and migrate them on. If they were running, say, another hypervisor like VMware, we can migrate those in.
But you guys are the hypervisor.
We are the hypervisor.
Yeah, and that's where that delineation ends.
Yes,
as the hypervisor.
So we really are a general application platform, and it's got storage, compute, resource. Yep. We manage all the infrastructure. This is not the way most customers think about it, but I think for technologists, this is like, for their perspective, this is like Amazon Cloud almost. But it's just a lot easier. It's like They don't have to worry about what's under the hood behind the scenes. They just, hey, I need these VMs, I need this many cores, this many CPU cycles, this RAM. Hey, can you run this? Can you run NT4? Yeah, we could run NT4, or whatever. And they don't have to worry about the care and feeding of what's underneath. Now, it's not a fully managed service at this point, so customers are, we provide full support. They don't have to be connected to the internet. We provide all the tools for them to manage and monitor those. in whatever form they want. Either we have complete dark sites that we're never going to touch their systems. They have all the tools that we have, and I'll go through some of those in a little bit of detail. So a wide range there. So.
Okay. And then you're focused then on building the resiliency on the back end so that when they deploy an app, like it's going to be, if there's multiple boxes there, it's resilient among
Right.
those
There's
things.
no such thing as putting an application on this that isn't redundant.
Right.
All the data you store is automatically distributed. We're monitoring that. If you create an application, it's, we by default pick the best location to run based on resources. If the node it's on go down, we automatically restart it on other nodes. So that's kind of the autonomy and so forth. Yeah.
That helped give me some context.
Okay,
I was just a
perfect.
little lost because I didn't have the background there.
Yep. No, thanks.
Dave, can I just ask you one more question?
Yeah.
In a traditional environment where you're racking and stacking in the data center,
Yep.
it's a lot easier to physically power those servers up and then configure them because you generally have equipment wherever you are.
Right.
But when you've got something like that where it's plugged on a wall and the front end connection is Wi-Fi and the back end connection is your own network setup, how would you typically see people configure those remote devices when they're first physically put in?
All right. Well, it's not my next slide, but it's 2 slides. So.
Perfect then. Okay.
But yes.
I can wait.
Okay, perfect. All right. So a little more on hardware, and I think Phil and Mike will probably go through a little bit more on some of the different hardware that we have up here through the demo. So we offer a wide range of hardware. Our standard flagship is generally 1U appliances, and this in a lot of retail organizations they have the cabinet up on the wall, and we can provide short depth. Nodes that are Scale branded. We also work with customers that, hey, I prefer brand XYZ and I want this, or we even talk to customers who, hey, I have this system. Can you work on these existing systems? They're Intel boxes. There are opportunities to do that. The appliances you can build to order and mix and match, and the appliance models, including a couple months ago, we announced our HE500 series, the HE being edge-focused, although it is applicable to others. And this was a 3-node high-availability 1U rack mount cluster with all the software you need, MSRP of $15,000 as a starting at price. And then single-node systems down to about $5,000 per server. One of the things we are, again, working with, we have customers running these in production. We have customers that are in POCs. There will be more detail announcements on some of the small form factor systems. But we can offer MSRP, a fully redundant system here with all the software for around $5,000 with no single point of failure, data redundancy, compute redundancy. And for a lot of businesses, that's about what they're paying for a server. And it can do more and scale out and all the benefits. So many of these systems would fall that you're seeing here would fall into that, and all flash or hybrid storage depending on the performance and capacity requirements, and we can work with them on specific hardware. So as an example, the HE500 series that I announced, it's a Scale branded appliance that actually was originally designed for our largest current active edge customer, which is a grocery store chain called Ahold Delhaize. We designed this with them. It's Lenovo-based gear. That's actually the picture you see up on the top. It's deployed to them as a pre-cabled, pre-racked systems with 3-node switches, software preloaded. They're the ones that deploy several stores a day at the rate they're going. And we developed it with them based on their footprint, their needs, found other customers were interested in it. So it's now available as an off-the-shelf, ready-to-go appliance. All right, and this, I guess, you can kind of see. So the range from, small edge core data center rack mount things that could do anywhere from 10 to 100 VMs, range quite a bit in price or RAM. Tiny devices, so this middle one is a Lenovo SE350, which is their edge-focused appliance. It's about the size of a large laptop, and it's got built-in networking. There's where there's space-constrained environments, things like that. It's scales up beyond some of these nano devices, which are generally pretty limited. I mean, that middle system that I showed, 4 GB is the RAM limit on that current system. That's all you can fit into that particular system. The NUC system on the left is 32 GB. In some models, you can go a little bit higher than that, but a totally different class of system. So this is just kind of give you a range of the devices that we could run on.
The slide before said AIML ready, so do any of them have the possibility to add accelerator cards? Or that kind of seems like a really small amount of memory to run.
Yeah, depending on what level you need, you'd go to a larger form factor. There are even some small factor devices that are coming out kind of for this, where you have a compute blade and you've got an empty slot that's kind of designed to put a GPU.
Okay.
But I don't know if you want to comment any more on.
Yeah, and depending on the workload, again, like if you're talking about like something like a gas station or a QSR where you've got a handful of camera feeds you might want to be doing analytics on, these type of machines can handle that load, in an AI ML analytics application. If you're moving into like something a supermarket or larger with hundreds of cameras, you're right, this might not cut it. You'd have to go a little bit larger, but yeah.
Okay. I'm going to skip through this one and get to one actually that we talked to answer the question. So a big thing in Edge, and one of the major things we had to work with our initial Edge deployment partners was on multi-site and fleet management. So Mike Lyon's going to go through a number of pieces of that. The two I want to highlight here are the imaging process, like how do you deploy these? We actually had hoped to have all the right pieces where we're going to basically take a NUC out of the shrink wrap, plug it in, put a USB drive in, and walk away and show how that can be zero-touch deployed, configuration, download from a central repository. We've worked with customers on that capability. That's built in for kind of the central configuration management database and to deploy those. That's the most common model. We've also worked with customers who literally want to do that on a USB. They do show up and they want to, before it's racked, do their own imaging, USB mount. So we have the capabilities to work with them on that zero-touch deployment. We also have cases where a lot of it's done in the factory, custom for them, so we can work with integrators that can pre-configure, preload things, just like with the Dalha's pre-racked systems. We can customize the remote support infrastructure. So in our normal end user flagship business, one of the things people like is the ability, if you do have a system or the system gives you an alert and says, hey, you need to call support. There's this event that we can't remediate on its own. The first thing they'll generally do is say, open a support tunnel. The system will phone home back to our support center. They have full access to all the telemetry to the system to make changes. Most customers at a 1,000 site location have their own operations center that want to handle that. We can provide them all those capabilities there, as well as things for how they centrally manage and apply and push out and schedule those updates. And as I mentioned, Mike Lyon's going to talk about the multi-system management, as well as a lot of the orchestration that's capable through API and Ansible and so forth. So the last piece really here is on the support side. We get great reviews throughout our customer base on the support and the ScaleCare support services that we offer. It's included everything from the network configuration, the initial deployment, disaster recovery planning, which in the SMB space a lot of companies need help with, VM migration. In the edge space, there's a whole set of new things that we offer from certifying custom hardware, rack level integration, custom monitoring. I want to be able to, this is how we monitor our other things within the store. Can you send events and alerts through that? We can work with that, as well as custom deployment orchestration tools. We work with them on lifecycle management, capacity planning. What's your 3, 4, 5-year plan on how you're going to evolve the infrastructure and keep it going. Pilot, POC projects, special integration with physical systems, IoT systems, special applications. We'll work with them on validating those as needed. And to kind of summarize, our goal is to provide a complete edge infrastructure solutions based on our hyperconvergence technologies for tens to thousands of IT sites. Everything that you need, software, hardware, management services, whether you need appliances off the shelves. And over time, these things that started off as custom one-offs for a particular use case, will become available. And do watch for some news on, some of the particular devices up here, kind of going through that life path soon. Wide range of configurations. We didn't really talk too much. We focused a lot on the clusters, which is the most common cases. There are use cases where, I can put one of these out in a remote site. I can replicate it back to another site or to a central location with the ability to fail over or switch over the application to a central location. No on-site expertise required to deploy or maintain. That's really the key aspect and key cost driver for a lot of these edge environments. Cloud integration we talked about, and then built-in backup DR as a service offerings where needed, and of course the ScaleCare support.